want to ask me whether is this curves streamline or path lines. I would say that this is path lines. It it actually meets all the points where the particle move. So at time 0 it is at this point, maybe at sometime it is this point. So you have so many points, so you just draw a trajectory. You have this curve over here, and then streamline itself is the gradient. Okay, as you can see, the gradient itself is steeper if you have if you have a higher gradient. Okay, when y is divided by x, right? So if you have a lower gradient, much lower gradient, you have you have a little more lesser and lesser steepness. So let's say if I change it to near to 0, so maybe let's say 0.01, okay, you can see that it's almost near the you see it's actually over here. So there is no gradient at all. So in this case, it's very clear that the streamline, it affects how this curvature of the path line will go. Okay, so if your curvature, if your gradient is lesser, you will move in a straight path. Okay, so if your gradient is more and more steeper and steeper, you will move in in this direction. Nonetheless, as I say, this curve itself, okay, generated is only applicable for the when c is equals to xy. Okay, if c is equals to x square, y square, cube, I mean to about divided by 3, the whole you will not see this curve anymore. You may see some swelling or whatever. The whole curve will go haywire. Okay, so maybe I should hold on. So actually my fault is that saying that if the value of c, okay, it's equals to some other values, you have different curve. Okay, actually I am wrong. Okay, I have higher chances of being wrong because I just plotted, you can see this is 3 times and so this is, as I say, this is the what's this called, the c value, okay, our streamline value divided by 3 times x cube. Okay, so if you 3 times x cube, as you can see, the curve is this line over here. It doesn't change, it follows the exponential thing. So as I change my exponential, as you can see, it becomes, let's say, A72. Okay, you can see that the whole trajectory has moved differently. Okay, the whole system has changed so much. Okay, the whole system has changed so much. You can see the whole graph will actually change in all different shapes. So apparently, I would think that it is the governing equation for x and y will cause a change in the path flow. I mean path line itself. Okay, so this is something that I've just found out also. So nonetheless, as I say, if you were to plot, yeah. So just to enforce again, okay, a different equation of x. Okay, a different equation of x. This is x value. These are the x and y values. Okay, you have a different equation. You have different configurations. Okay, as I say, if you were to, let's say, let's put exponential. Okay, let's put some maybe, hold on a while. As you can see, if I put instead of exponential, okay, that's now is exponential. If you were to see, okay, sorry. So you have this line over here, right? So if I were to put it in terms of square root, okay, if I were to put it in terms of square root, the whole system changes. That is interesting. Okay, so you see, you have a motion in this, so the whole system would change. Okay, but nonetheless, if you were to ask me, um, So the higher value of the streamline itself is it affects this thing. But however, I have no idea. So this exhibit a very interesting thing. Okay, as you can see, this also previously I say that the higher value of C, you have a lower curvature. Only in the only in this scenario, then it is. But you see in this scenario, our xy is actually, maybe I should plot this. Yeah. Okay. Hold on. Okay. Anyway, so as you can see, the curve, if your in our case, if our streamline C is actually 1, it's actually shoot up. Okay, it's not at the highest point. So it's a little weird, I don't know, but nonetheless the rest follows the curve. So you see the highest is actually at when streamline value is 7, and then the slightly lower one is streamline value is 6. And then eventually at this point is 2, but interestingly at streamline at 1, um, yeah, I actually have a infinity thing going up, and the whole thing, it's pretty interesting how it goes. Okay, so yeah, let's get back on track. So just to give a recap, we do pathline, we do streamline. Okay, we talk about it quite a lot, and then we also visualize how the streamline would flow, obtain an equation for the streamline. We actually have discussed pretty much a lot of things. Okay, saying that different equation for the x and y will have different shapes on the graph itself. Pretty interesting. And then we derive the string function. Okay, that is the design. This thing I explained. Okay, and then we know that xi is equal to some c constant. And then now we may actually need to do some examples so to let you understand how this. So we'll use the general equation to actually solve for the spray case. In other words, previously we actually derived c equals to xy, right? This one is actually the spray case already, okay? So what do I mean, okay, if I were to go back to the equation? So as you can see, when you have a spray over here, and then you spray the and then you spray onto this wall, right? So the trajectory of your particle, the spray itself, will actually move in this motion, right? So it actually shows you the pathway, the path line of the thing, and then the gradient itself all depends on how much streamline it is in this case. And then at different time, okay, at different time you have different plots x. So at time 0 is x is this x and y is in this position. At time slightly more you have x and y in this position. And then so this graph explains time, explain x position, explain y position, and explain how the streamline gradient affects the path line itself. Okay, so that is pretty interesting. Okay, and then nonetheless, we this is the equating part that we're actually talking about when we derive our streamline. So but we didn't use a general way of actually deriving the streamline. So in this case, this is why I actually will talk about it now. So imagine if you were to go back to this question, okay, stating all these things. Let's paste it over here. Okay. So maybe I paste it over here. So you can know that the xy, the x, okay, the ax, as we said earlier, is the u, okay, in the x direction because of the I hat, okay, stating that it is x direction, and then y hat is stating that it is going in the y direction. So a minus ay is actually v, okay. So each of them, so this is the velocity of the particle in x direction. This is the velocity at y particle in the y direction. I mean, yeah, why the position, the velocity of the particle in the y direction. So as you can see, u is equals to partial xi over partial y. This is an understanding from where we just now we have talked about it, right? U is equals to, u is equals to this thing. If you remember the exact equation. So we just sub in all the u and the v. So this is a very important concept you need to remember. Okay. So ax, okay, ax is equals to, so as we know, u is equals to ax. So since u is equals to partial xi over partial y, so ax is equals to this. And then in order to solve for xi, you need to integrate, right? So you bring, what do you do? So I'll just bring the partial y from the denominator upwards, and then integrate. Okay, integrate already, you have ax y, and then plus some function of x, because this is the method where you do exact differentiation, if you remember. So if you were to have if you differentiate some value of y, definitely the x will be gone, right? If you differentiate this whole equation in terms of y, okay, only the y gone. But however, because ax is a constant, but however, if you differentiate a constant that is not y, it will just go to 0. So this is where it is. Just a simple explanation. And then hold on, yeah. And then if you were to differentiate, because you want to eventually solve for the equation itself, okay, you want to know what is actually xi. So you differentiate one time, okay, partial xi in terms of partial x now, okay, you get this one, okay, ay. So you differentiate x, you have ay plus the derivative of fx, you have this, and so you have this this equation, right? So therefore, since you also know that v is equals to minus partial xi over partial x, so you have to be very careful, because minus v, from here we see that minus v is equals to plus del xi del x. So in this case, since this is del xi del x, we just bring the minus. At first is minus v, sorry. At first is minus v equals to del xi del x, right? So let's bring this minus over here. Okay. But nonetheless, since this is del xi over del x, so this is equals to minus v. I think you go ahead and win already. Because yeah. So we can just say that this is minus v, and since v is equals to minus ay, then minus ay, you have positive x ay. And then you just bring this ay over here, and then you have 0. And then you know that f prime x is equals to 0. You differentiate one time, you get fx is equals to c. And the fx, so you sub back into, because this is the original equation xi, right? Because the purpose we want to do all this over here is actually to find what is fx. So in this case, fx is some constant c. So let's set back in. We have xi equals to this equation. So compared to just now, xi is equals to c, because we are just using a simple derivation. We have no any values, okay, because u is just u, v is just v. That's all, right? But in this case, u is equals to ax, v equals to minus ay. So as the equation becomes more complicated, maybe ax squared plus something, your whole xi equation will become more and more complex. And this xi, so what is this xi? So if you remember, you are taking v divided by u, right? You're talking about string. Stream is actually the gradient of the x and y velocity, right? So this xi is actually the stream value. Okay, it determines how steep your graph would be, right? How steep your graph would be. So yeah, so a different values will affect how this steepness will go. Okay, so I've talked too much already. Okay, so in the next video I actually go to some path line examples, trying to find x and y. Okay, so eventually we will know how to plot this graph over here, because just now we say that x is in terms of some equation, exponential equation, right? But I haven't proved to you that how we got this equation over here. So in the next video I'll just talk about it. So I'll see you in the next video.